Okay, guys, the first thing I want to say about our notes is to make sure you have a pencil. Make sure you have a pencil. Make sure you have a highlighter, a yellow highlighter. And you may also get out your calculator, okay? Because we're going to do a couple of things today. We're talking about powers and exponents, okay? There's a lot of vocabulary to hit here that we need to know and understand because when we start having our mathematical conversations, we're going to be using the big words. So starting with your name, make sure your name is at the top of your notes. Because if you lose your notes, I would love to have them returned to the proper owner. And we're in topic 2. All right, so let's start with our vocabulary. So powers and exponents. In the case of repeated multiplication with the same factor, the product is called a power. And it can be written in exponential form using a base and an exponent. Now that's a lot. That's a lot, okay? So, when we have repeated addition, we call that multiplication. So just think of repeated multiplication is called a power, okay? But with the same factor. Remember, the factors are numbers we multiply together. So we're going to highlight that whole thing. We're just going to know that's important, okay? But we're going to break it down. We're going to break it down. So for example, we can write 3 times 3 times 3 times 3 as the power. So what you would do is you multiply it. So 3 times 3 times 3 times 3, 81, okay? But breaking it down more, the base of the power indicates the repeated factor, okay? So the base of the power indicates the repeated factor. Now the base, think about base, it's the bottom, right? It's what holds something up. So in this case, 3 is my base. It's also my repeated factor. So I'm just going to do like this and say this is my repeated factor. Okay. 4, the exponent indicates the number of times the base is used as a factor. Okay. So 4 is my exponent. So what I want you to understand, this is the same thing as this. Okay. So we're going to write each expression in words so that we can use that vocabulary. So we have 3 to the power of 1. Look at me. Didn't use my words. 1. You need to write the words out. Please, I don't want to come by and see that you put 3 in a 1. Like the word. Write it out. Next one is 3 to the power of 2. 3 to the power of 3. 3 to the power of 4. And 3 to the power of 5. Okay? So now we're going to write our powers, okay? So expanded form is repeated multiplication, okay? Exponential form, I'm going to take my factor 7, okay? That becomes your base. And then for the exponent, how many times am I multiplying it by itself? Well, I'm going to count 1, 2, 3, 3 times. Okay. This next one, expanded form, my factor, my base is 12. And then how many times did I multiply it by itself? 1, 2, 3, 4, 5, 6, 7, 8. And then we have, okay, hear me out now. We have a mix right here, okay? But is it doable? Yeah, it is. We just have to put our little thinking caps on and take a bite of my breakfast. All right. So we do have repeated multiplication, but I have 4 times 4 times 9 times 9 times 9 times 9 times 9. Okay? We can do this. Starting with 4 is my first factor, my first base. How many times did I multiply it by itself? 1, 2. Times, what is my next base? 9, my next factor. And how many times did I multiply it by itself? 1, 2, 3, 4, 5. Okay, the next one, I'm just going to break this one up, 25. And this time I'm going to say how I would read it, okay? So 25 to the power of 1, 2, 3, 4, to the power of 4 times 3 to the power of 1, 2, 3, 4, 5, 6. Okay? Okay. So, now in reverse. So, my base is 1, okay? And my exponent is 5, meaning I'm multiplying 1 by itself 5 times. So 1 times 1 times 1 times 1 times 1. 1 is my base, repeated 5 times. 16, how many times am I multiplying it by itself? Yes, 11. So you got to count that out. 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I get it right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? That's a lot. And this one, we have 2 examples that are similar to 3 and 4. So my base is 2. I'm multiplying it by itself 3 times. 1, 2, 3 times. My next base is 9. I'm multiplying it by itself 7 times. 3, 4, 5, 6, 7. And then my last one, I have 10 to the power of 6 times 28 to the power of 2. My first base is 10, multiplying it by itself 6 times. And then 28. Okay. All right. Now we're going to evaluate powers, okay? We're evaluating powers now. Pause a moment. Son, don't forget to ride the bus home, please. Thank you so much. I love you. Goodbye. Okay. Find the value of each power. So I'm going to show you a couple different ways that you can do this. Because if you're not using this calculator, you're using the one that I gave you at the beginning of the year, you type in a little bit differently. But we're going to take it and we're going to write it to expanded form. And I'm not asking you to do it, I'm telling you to do it, okay? So expanded form of 6 to the power of 2 is the same thing as 6 times 6. Now, if you have your calculator, you can obviously multiply 6 times 6 if you don't know those facts. But with this calculator, to do exponents, where's my exponent? Where did you go? Oh, there it is. We don't want that one. Okay. 6, see my little arrow pointing up? That is going to reference an exponential form to the power of. See that? Woohoo, pretty. And then put your exponent there and you hit enter and you get 36. That was pretty mind-blowing. Okay, so number 10, 14 times 14 times 14. I encourage you to work on using that exponential form in your calculator. So 14, my little arrow to the power of, and we have 3 this time, and we get 2,744. Excuse me. Number 11, we get 8 times 8 times 8 times 8. And then in my calculator, I type in 8 to the power of 4, 4,096. All right. 2 to the power 6 times 14 to the power 2. So 2, 3, 4, 5, 6 times 14 times 14. So here's what we can do. Just show where this is expanded. I want you to do expanded. I want you to know that. I want you to be well versed. So we're going to do 2 to the power of 6. Okay. Times 14 to the power of 2. Woo, that's a big one. Okay. Another way, I'm going to show you this. If you're feeling fancy in your calculator. Okay. Also this. 2 to the power of 6 times to the power of 2. Okay. What? No. I guess we can't. It won't let us. Oh, don't do that. You see what I tried to do? It didn't work. It didn't work, so don't do that. Okay, so here we have it. Now, 13, 14, 15, and 16, we are comparing the values, okay? And we've been comparing all year long. You know, it's what we do. It's what we do as middle school people. We compare ourselves. We compare our math. We compare our reading. All the things. So you need to evaluate. So I'm going to show you how I expect this to look, okay? Because if you don't do it the way I expect it to look and you're getting it incorrect, I'm going to ask you why you don't want to do it the way I showed you to do it. So we are going to evaluate it. You don't need to write expanded this time. Evaluate it. So 15 to the power of 2 is 225. 3 to the power of 5 is 243. That you need to evaluate it so you can then determine if it was less than, equal to, or greater than. Less than, greater than, equal to. There we go. Now I have 6 to the number 14, 6 to the power of 4, and I get 1,296. And then 11 to the power of 3, 1,331. Clearly, it's greater. Then I have 2 to the power 7, 128. And I have 7 to the power of 2, 49. Here we go. 4 to the power of 6, 4,096. And then 5 to the power of 4, 625. So here we go. Okay, that's it. That's all I got to do, evaluate and compare. So we have powers of 10. So powers of 10 are a little bit different. They have a little bit of a pattern, and I want you to notice that. If you're with me in class, we'll talk about it. And if you're not with me, we'll talk about it on my video right here as I continue to talk to myself. Okay, so expanded form, 10. Expanded form, 10 times 10. 10 times 10 times 10. Base 10, multiplying it by itself, 4 times. Base 10, 5 times. Okay, so, well, 10 multiplied by nothing is itself. 10 times 10, or you can do 10 to the power of 2. 100. Seeing a pattern here. 10 to the power of 3. Keep going, my lovely friends. I hope you see the pattern as I already know. I'm going for a wild guess. I'm going to say there's going to be 5 zeros. So I'm going to go for a wild guess. Whoop! Look at that. Oh, I hate it when I'm right. Oh. All right. So what patterns do you know to the power of 10? I feel like I'm on Dora the Explorer. I'm going to talk to myself. Well, Miss Collins, for every power that we increase my 2 zeros to my 1 over here. 10 to the power of 3 is going to be 1 with 3 zeros. Yes. So, as we increase the exponents, we increase the zeros by 1. So, 10 to the power of 3 will look like a 1 with 3 zeros. We're going to draw a little arrow up there to be like, girl. So what I'm saying is if you're doing a little T-cappy or a little quizzy quiz or a little testy test, don't put it in your calculator. You see this pattern, you're like, dude, 10 to the power of 3, 1, 0, 0, 0. 10 to the power of 7, 1. And then 0, 0, 0, 0, 0, 0, 0. Okay? That's all it is, my friends. That's all it is.